Good morning, and today we'll be looking at addition and subtraction of vectors. So here we have three vectors. So we're first of all going to look at them using the diagrams, and secondly using the components. So if we want to construct a plus b, we will start off by drawing vector a, and we will join that together with vector b. Now notice the front of vector a is joined to the back of vector b. The front of a vector, following the direction of the arrow, the front of the vector is called the tip of a vector, and the back of a vector is called the tail of a vector. And when we join vectors together by adding them, we join them tip to tail. That's the expression we used. So vector a plus b is actually the direct vector that goes from the beginning of vector a to the end of vector b. And that direct journey is the journey that represents a plus b. So a plus b means, using the diagrams, vector a followed by vector b, tip to tail. Okay. If we want to construct a plus b plus c, we will do so with the three vectors. So start in the order, vector a, then join on vector vector b. So a followed by b, and then followed by c. And c, the direction of vector c, again tip to tail. The tip of vector b to the tail of vector c. And the vector that is created with these three vectors added together is represented by the red line, and that is the vector that represents a plus b plus c. So that would be a followed by b followed by c. Now we want to consider a minus b. Now just remember that a minus b is the same as a plus minus b. So let's think about how we can construct minus b. Minus b is very similar to the vector b. It will be the same size, but the direction will change. It simply means that it is the vector b going in the opposite direction. So here we have exactly the same line as we had before, but the arrow in the middle is showing that the vector is starting here and finishing here, going in the opposite direction. So it goes in that direction as opposed to that direction for vector b. So minus b is just b in the opposite direction. They have the same size. The magnitude of b is exactly the same as the magnitude of minus b. So this is how we can construct a minus b. So we start with a, and then it's minus b that gets added on, tip to tail. Okay, so we have minus b being added on, so that goes in that direction. And then a minus b is the direct vector that is created from the start of a to the end of minus b. So it's going from there directly to there. That's the direct vector, the direct journey to go from the start to the finishing point in the direct route. So a minus b just simply means a followed by minus b. When we have components, things become much simpler. Very simple and straightforward. So these two vectors added together are very simply the top two components added together and the bottom two components added together. The same with subtraction, so it's even easier when you're doing it with components. Okay, so if we have these vectors here, u plus v will be 1 plus minus 1. Just be careful with your negatives, and 5 plus 2. So 1 plus negative 1 is 0, and 5 plus 2 is 7. u minus v, 1 minus minus 1, watch your double negatives, and 5 minus 2. So we have 1 minus minus 1, 1 plus 1, which is 2, 5 minus 2, which is 3. Okay, and here we have a little problem involving vectors. A boat is travelling due north at a speed of 10 kilometres per hour. The current travels due west at a speed of 4 kilometres per hour. So first thing we want to do is draw a diagram to show the resultant velocity of the boat, and then calculate the resultant speed of the boat. Now when you're asked for the resultant of two vectors, it's another way of asking you to add the two vectors together, tip to tail. So here we have a vector to represent the boat travelling due north, so it's going in a north direction. Okay, I've named that vector b as well, and I've also written beside that it's 10 kilometres per hour. So it's travelling due north at 10 kilometres per hour. The current travels due west, so that would be going in that direction. So there's a C for the current, travelling due west. So those are the two components there, and when they go together, what we have now is the journey that the actual boat will be taking when you take into account the current. So that's the journey. That's the resultant velocity. That's the journey that you would be actually taking on that boat, given that the current is travelling due west. Okay, so calculate the resultant speed of the boat. So you can see here we've created a right angle triangle, so we will simply use Pythagoras. We square these two numbers and we add them together because we're finding the longest side in Pythagoras' theorem. And then we square root them at the end. So we end up with 116 and square root of that, 10.8 kilometres per hour. Okay, so that's a practical problem there. We're also going to have a very quick look at the zero vector. Any vector with all of its components, 0, is called a zero vector, not really a surprise. So every number for every component would just simply be 0. Okay, so we're now going to have a look at exercise 13C and 13D today. And you can see the list of questions that are there. Any problems, make sure you message your teachers. One of us will pick up your message and give you some help. Okay, thank you. Have a nice day. Take care. Bye-bye.